Okay guys, before we do our note card for today, this is what I want you to do as a warm-up. Since we don't have a whiteboard warm-up today, obviously, I want you to work in your groups on 2003 AB5. This is a free response problem, 2003 AB number 5, Form B, and this is another function defined as an integral. So I want you guys to take some time in your groups, and I want you to see what you can do with that. I'm going to present the answer key on the video here, but I'm going to ask you, once you have found this paper, to pause your video and work this in your groups, and then check the answers off of the key here. So go ahead and pause the video now and see what you can do with this problem. Okay, here's what you should have gotten. I'm going to scroll up and show you this work. And I hope that you have made a good faith effort to do this. And if there's any issues you want to correct, and if there's something that you just don't understand how we got to this, then that's something you want to make sure that you highlight and ask me when we meet again together next week. And we will be turning this in. So there's A and B and C and D. So once again, part of your assignment will be to do any corrections you need to do on this. Okay, moving into note card 68. Solving separable differential equations. This should be the last note card in your fourth 6 weeks material. So a differential equation is simply an equation that involves a derivative. So it has dy dx in it, or maybe y prime in it, which is the same thing as dy dx. Separable means we can actually get all the y's and dy's on one side and all the x's and dx's on the other side. Some differential equations are not separable, and you cannot solve them algebraically. And then we have to look at other means that we will investigate in the start of the fifth 6 weeks material. But these are going to be ones that can be separated, which means they can be solved algebraically. So here is going to be our procedure. We're going to separate and integrate. When you think of note card 68, differential equations, I want you to think separate, integrate. We're going to separate the variables, we're going to integrate both sides. Then we know when we integrate an indefinite integral, we'll have a plus c involved. If there's an initial condition given, we'll find c. And then finally, once we have c, we'll put in that value for c, and we will solve for y or f of x and get our final answer. Okay, so let's put these 4 steps into practice on number 1. I'll slide the paper up here, and this is straight off of an old free response problem. Oftentimes, differential equations are on the free response, and they are worth a lot of points for work along the way. So this is the last thing in the world you ever want to leave blank. You want to do work on these. Find a solution y equals f of x. That just means solve for y. That's all that means. For the differential equation, dy dx equals 3x squared over e to the 2y, satisfying the initial condition that f of 0 equals 1/2. Okay, so we're going to follow our procedures, and we're going to separate first. This separation looks pretty easy. We're just going to cross multiply. Separation, remember, means get all of the y's and dy's on one side and all of the x's and dx's on the other side. We have now done that, and that would be worth 1 point on a free response problem on an AP test. That would be worth 1 point right there. Now we're going to integrate. So integral, integral. Notice I already have the differentials here, so I don't normally when we draw an integral we have to put a dy or dx, but they're already there. So we are going to integrate both sides now. Well, let's think about our shortcut here. We can avoid a u substitution here. The antiderivative of e to the 2y will be e to the 2y times the reciprocal of the derivative of the u. So the derivative of this u is 2, the reciprocal of that is 1/2. This side, 3 is a constant multiple, it can be left out. And then this is x cubed over 3. Well, the 3's are going to cancel out, aren't they? So the antiderivative of 3x squared will be x cubed, and I need a plus c. And you have just earned 2 more points. 1 point for integrating this side, 1 point for integrating this side. And oftentimes you get a point just for having your plus c there. So it's very possible that that would have already been worth 4 points. So you see the points really rack up quickly here. Zooming on that just a little bit there. Okay, so we've separated and we've integrated. Now we're going to use our initial condition, and we're going to find c. The initial condition for this problem is that when x is 0, y is 1/2. So we're going to put in a 0. I'm going to come over here and do this work over here and then go back to my main work. You don't have to do it that way, but this is certainly one way you can do it. I'm going to come over here and I'm going to replace y with 1/2. And I'm going to replace x with 0. Well, 0 cubed is just 0, so I have c by itself. That's easy enough. 2 times 1/2 is 1, so I have e to the first, which is just e, so I have 1/2 e. So c is 1/2 e. So now I'm going to come back over here to my main work, and we're going to replace the c with 1/2 e. Now we need to solve this for y. So this is really just algebra 2 from here. So what we want to do, might want to go ahead and get rid of the fraction first. So if I times every term by 2, that is the denominator, I will get rid of the fraction. So let's go ahead and do that. That should be the results of timesing every term by 2. Now I need to think about how am I going to get y by itself. Well, y is trapped here as an exponent on e, and we know that we are going to get rid of e's with ln's, hopefully you are saying. Now this side has 2 terms, so when I do an ln there, I want to do a parentheses around that. That will break out this 2y, and here I will have the natural log of quantity 2x cubed plus e. I can simply divide by 2. Dividing by 2 is the same as timesing by 1/2, so you might see the answer presented like this. Instead of a fraction, they might consider this more simplified. And we know that with logs, there are other ways to do this. You could make this into make this coefficient into an exponent now, and have the natural log of this quantity to the 1/2, which means you could write this as the natural log of the square root of all of this. So once again, this is a perfectly valid answer, and on a free response, you should stop. Remember, if it was on a multiple choice and you needed to keep going, maybe this would be a final answer here. And in that case, you would just let the multiple choices guide you as far as what log properties you need to utilize. But let's go ahead and use this box answer as our note card test version, because that would be where I would want you to stop on a free response, and that would be worth full credit there. Okay, I'm going to move up now. Let's look at number 2. If dy dx equals 2y squared, and if y equals -1 when x equals 1, then when x equals 2, y is what? So we got a little bit of an extra step here because we're going to need to find our solution and then use the solution to find another value. Other than that, everything's the same. So we're going to start. Notice this is all of these are straight off of the old test on this note card. So we're going to separate and integrate. So often that can be done in one step. If you just think about it here, I can times by dy while also dividing by y squared. So if I do that, I think I said dy. Let me see if I can. I times both sides by dx and divide it by y squared all at the same time. So make sure that you feel good about what we did right there. Okay? Okay, now I'm going to write this as y to the -2nd dy, because remember, we're getting ready for integration. So I always want to use the power rule for integration, meaning bump up and divide whenever I can. So now we're ready to integrate. And y to the -2nd, bump up and divide, that will be y to the -1 over -1. And the antiderivative of 2 with respect to x, we know is 2x, and then this side gets the plus c. Okay, well, now we're going to do some side work over here, but before we do that, let me go ahead and simplify this side a little bit. We know that y to the -1st over -1, we've done this a lot. It ends up becoming -1 over y when you move the y's back down. And so I have -1 over y equals 2x plus c. So, if I wanted to let this stay my main work, I could come over here on the sidebar and find c. The initial condition is that when y is -1, x is 1. Y is -1 when x is 1. So let's come over here and put in a -1 for y and a 1 for x, and let's find c. -1 divided by -1 is 1. 2 times 1 is 2. So it looks like c is -1 with just a little bit of algebra 1 work there. So now I come back to my main work, and I have this. Now, I could solve this for y right now. However, since they are simply wanting to know what is y when x is 2, If you wanted, you could go ahead and plug in the 2 for x now, because there's nothing that said that we had to get a formalized answer like in number 1. So I don't have to necessarily get to y equals before I plug in the 2 for x. So if you feel better about doing this, which might be easier, go ahead and plug in the 2 for x now. And let's find y. So I have negative 1 over y equals 3. Because 2 times 2 is 4, 4 minus 1 is 3. And now we're going to times both sides by y. And that will leave me with 3y equals negative 1. Just a little cross multiplying there. Divide by 3. And y is negative 1/3. And that was straight off of an old multiple choice problem on an AP test. Okay, take a second to make sure you feel good about 1 and 2. And we're going to scroll up here and look at the last problem on the note card. And the last one is also straight off of an old free response. Find y equals f of x by solving the differential equation dy dx equals y squared times quantity 6 minus 2x with the initial condition that f of 3 equals 1/4. Same thing, guys, separate, integrate, and remember how many points along the way here. These are used, when you see a free response that involves a differential equation, it will probably only have 2 parts to it, an A and a B, because they are worth so much. This part of it, which is usually the last part, is worth like 6 of the 9 points, sometimes 7. So leaving this blank would be a terrible idea, right? You get so many points along the way. Okay, so hopefully as I was talking there, you maybe you're thinking about ways that you could separate this. And I'm thinking that we could divide by y squared while also timesing by dx. So if we combine those two things, and if you don't feel good about combining these two algebraic steps, then do them separately. You don't have to do them all in one step. But we divided both sides by y squared while also timesing by dx. And that's a 2 there, got a little messy there. Okay, so we have now separated. We're ready to integrate, but we don't want to integrate with a y squared in the denominator because that can easily be changed to y to the negative second. And now we are ready for our power rule for integration, which is commonly referred to as bump up and divide. So y to the negative first over negative 1, which we've seen that before, equals, now I have 2 terms here, so one at a time. Antiderivative of 6 with respect to x is 6x, and the antiderivative of negative 2x, the negative 2 would hang around at least for a second, and x becomes x squared over 2. Well, those 2's are going to cancel out, and I just have the negative x squared. And of course, this side gets the plus c. So just to reinforce here, you've earned a point for separation, you've earned a point for integrating y, you've earned a point for integrating x, and you've earned a point for the plus c. So you've earned 4 points. Okay? The 5th point usually comes from using the initial condition, just using it to find c. And so to do that, let me get this ready for algebra though, because we don't want to leave this like this. We know that's negative 1 over y, not x, negative 1 over y, equals 6x minus x squared plus c. So let's go ahead and earn that next point by using the initial condition. So it says that when x is 3, y is 1/4. So let me put in a 1/4 for y and a 3 for x. And I'll tell you what, I'm running out of room here on this side, so why don't I come down here and actually do this in my main work this time, okay? So that we can see a little bit better here. So negative 1 over 1/4 equals 6 times 3 minus 3 squared plus c. This is a negative 4 here because dividing by 1/4 is the same as timesing by 4. And I have 18 minus 9, looks like I have 9 plus c there. If I minus 9 to both sides, it looks like c is negative 13. Okay, so I'm going to use the last line of my paper here and go ahead and put in my c value now. Negative 1 over y equals 6x minus x squared minus 13. Plus c has now been replaced with minus 13. So we have earned a point for separation, 2 points for integrating, that's 3, a plus c point 4, using the initial condition 5. The 6 points going to come from solving for y. That's the way the rubric was designed when it allotted the points for this problem. So to solve for y, it looks like I can times both sides by y. If I times both sides by y, that will get rid of the fraction on this side, and I will have negative 1 equals y times quantity, 6x minus x squared minus 13. So I can now divide both sides by this parentheses, and I have negative 1 over 6x minus x squared minus 13. This is a free response, so stop, stop, stop right here. Could you have made this look differently if needed on a multiple choice? Sure you could have. You could have rearranged the denominator so that the x squared was first, or negative x squared. And then, a lot of times we don't like to have a negative x squared and a negative 1. You could have times everything by negative 1, changed all the signs, and that would have been okay to do as well. But there's no reason, that would be timesing by negative 1 over negative 1, I should say, right, to do that. But there's no reason to do any more manipulation on a free response. Just stop right there. And that is full credit, and that is note card 68, solving separable differential equations. Okay, in addition to finishing up the warm-up free response that we showed you with any corrections you needed on that, here is your actual homework assignment. Due next week. You have notes on solving differential equations. This is 2 pages, but it's just 6 total problems. Okay? And then we want to make sure we can still handle the force. So one more practice problem on using the force functions defined as integrals. This is 2004 AB5. This will be before the note card that we just did. So notes on solving differential equations, 2 pages. Here we are. Notes on solving separable differential equations, and then 2004 AB5. And that will be due next week. And you can spend the rest of the class time getting started on those and working in your groups.